All right. Okay, so this is the last lesson that we're doing for logs. So logs were after today's lesson. That's the last lesson. So we've done. I think this is the fourth lesson. Next week we have a quiz. Next week we're gonna have a quiz on logs. So tomorrow we'll have a regular assignment like we always do in Delta Math, and then Friday and Monday we'll review for the quiz. Okay. Tuesday we'll take the quiz. All right. So the last thing is using logs to solve exponential equations. So before we even get to solving equations, something called the change of base formula. Change of base formula. What is it? Why do we use it? Well, let me give you an example. You don't have to write this example down, but I just want to give you an example. Okay, so you guys have been doing stuff like this, right? You guys have been doing this. When we solve this, right? We put a little question mark here, and then we say we use the e, right? And we say 7 to what power equals 49, right? 7 squared, right? So the power is 2. That works. That works. But what happens if I give you something like this? What happens if I change this up a little bit? What happens if instead of 49, I change it to 48? You can still use the e, the loop, but it becomes a different problem, right? 7 to what power makes 48? I know what power makes 49, 2, but now it becomes something like I can't do it in my head because it's not going to be a whole number, right? It's not going to be a positive number, it's not going to be a negative number, it's not going to be a fraction. It's going to be a decimal. Now the answer is going to be close to 2 because 7 squared is 49 and this is 48, so it's going to be close to 2. But how can I get something close? How can I get a better answer? Well, you're going to use the change of base formula. So we'll do it in a second, but what the change of base formula says is so let me pause real quick 1 second. Your calculators. On your calculator, there's a log. There's a log button. You go to the functions, and then there's a log. Right? Problem is, the only base this calculator does is base 10. Only base it does is base 10, because remember, if it doesn't have a base, it's base 10. The problem that I'm doing right now doesn't have a base of 10. It has a base of 7. So how do I get around that? Well, that's what the change of base formula says. The change of base formula says you can use base 10, but you're going to move the top, or you're going to put 48 on top and 7 on the bottom. So now when I go to my calculator will do that. 48. Oops, no. Seven. And I get 1.9894. That's really close to 2. That's what I expected. Okay. Because if I try to put this answer, like, oh, let me just put, so if you, some people look at this right here and they're like, oh, just put log of 48. Just put log of 48. That's not the answer. It's close, but it's not the answer, right? So this is how to better approximate them because scientific calculators you can't change the base on scientific calculators. They only give you base 10 and base E. Every other base, they don't give you. So this is a way of doing it, kind of a workaround. Okay? That's how we do it. So let's go, that's the change of base formula. That's what the change of base formula says. So let's look at 1A. Let's look at 1a. Again, normally you guys have done problems like this. Normally what you would do is you would say, oh, okay. So I'm going to go use the E. 8 to what power equals 30? Well, 8 to the first power is 8. 8 squared is 64. So it's somewhere between, the correct power is somewhere between 1 and 2. How do I get closer to that? You can use the change of base formula. So to use the change of base formula, what we would do is we would say regular log 30 over regular log whatever the base is. That'll give us an approximate answer. And then we're going to round that to the thousandth. Okay? So we're going to go to our calculator. So take your calculator, whether you're on the app or whether you're on this guy right here on the website. You're going to go to log. Well, first of all, you're going to use division. We're going to use division. We're going to have log. The top is 30. To get the log, you hit the function button. And then you have log. Log of 8. Oops, not there. We said the answer was going to be between 1 and 2. It is between 1 and 2. 1.635630,199. Okay. They want us to round to the nearest thousandth. The thousandth is the third place. The third place. So the thousandth for this guy, the 5 is in the thousandth. Right? The 5 is in the thousandth. So we look to the right of it. 6 says round up. So we're going to write 1.636. 1.636. That's our rounded answer. That is the power. That is the power that would make it equal to 30. I'll show you. If I were to take 8 to the power of my previous answer, 8 to that power, that'd be 30. Okay. Okay, so next one, 2b. Same thing, right? If we do the loop trick, if the loop works, use it. But sometimes it won't work. 9 to what power makes 4? I don't know. Okay. So we could use the change of base formula. So we say log of 4, log of the big number, divided by log of the small number. Log of the big number divided by log of the small number. Log of 4. Log of 9. And there you go. We're going to round to the nearest thousandth. The 0 is in the thousandth. The 9 after it says round up. So 0.631. 0.631. Okay. If it's a natural log, you can just use the natural log button. Natural log always has a log of, because remember this means, right? So the base is always going to be E. So for natural log, you don't have to use the change of base formula. You just use the natural log button, the LN button. So you just say natural log 50. e to this power makes 50. Okay? So if we round it, 2 is in the thousandth. The 0 behind it says stay, so 3.912. Okay. We're going to need to do that today. On the back, we solve. But now what we're doing is we're finding the powers using the calculator. So when the loop trick, when you can't do it in your head, this works. Okay? All right, so let's go back. So we're solving. Okay? So when we're solving equations, exponentials, there's no log. Look at 2a, there's no log. We're not solving log equations. We're using logs. We will use a log, but we're not solving log equations. Okay, these are equations with exponents. So the first thing we have to do after we draw our line is step 1 says isolate the base and its exponent. Well, since it's an exponent, 10 is the base. The exponent is x divided by 5. This is the base and its exponent. It's already by itself on the left side. It's already by itself. I don't have to do anything. So I can skip that step. Step 2. The only way to get the x out of the sky and bring it down to the ground is by using a log. So we haven't done this in a while, but we have done it. Change this from an exponent to a log. So instead of using the loop, we're going to use the L. We're going to use the L. We haven't done this in a while. I think the first or second lesson we did this, and we haven't done it since. This is where we bring it back. Okay, so when we're using the L, first of all, we're changing it to a log, so we got to write the word log. The first thing I hit, what's the first thing I hit when I did the L? 10, right? That's the base. And then I went over here and I hit 57, right? That goes right here next to it. And then I hit the power. The exponent goes over here. Okay, so now it's a log. I've changed it from an exponent to a log. How do I get, now I have to solve. Get x by itself. X is right here. So how do I get x by itself? What do I do to get x by itself? Something you guys have done many, 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 many times. How do I get x by itself? Right? It says divided by 5. So the opposite of divided by 5 is multiply by 5. So x equals 5 times this guy right here. So now what I'm going to do is I'm going to use my calculator to round my answer. Approximate by rounding. So what I'm going to do in my calculator is I'm going to write this part first. But remember, to write this part, I have to separate it. Log of 57 over log of 10. Okay, so I'm going to go to my calculator. Log 57 divided by log of 10. But then I had this multiplied by 5 at the end. So now I'm going to take my answer and multiply it times 5. Previous answer, so previous ANS, Delta Math, and Desmos has the same button, times 5. That's my answer. Okay. It says round to the nearest hundredth. The 7 is in the hundredth. So I look to the right, that's a 9. So change the 7 to an 8. 8.78. Okay. Let's go to the next one. All righty. I need to isolate that guy. First thing I need to do is isolate the base and its power. So 3 to the 3x, I got to get by itself. Well, right now I have a 50 in front. So how do I get rid of the 50? Divide by 50. Divide both sides by 50. 50 divided by itself makes a 1. So I have 3 to the 3x equals, I'm not going to change that to a decimal. Leave it as a fraction. You can reduce it if you can, but I don't think I can reduce 9 over 50. 3 goes into 9, but 3 doesn't go into 50. 9 goes into 9, but it doesn't go into 50. Okay? So part 1 is done because I got the base and its exponent by itself. Change it to a log. Okay? Log base of 3. This is the answer. 3x is the exponent. Okay? Get x by itself. Last step. How do I get x by itself? Divide everything by 3. Okay? So now I'm going to use the calculator. But just remember, when you use the calculator, you're going to do this part first. You're going to say log of 9/50 divided by log of 3. And then you're going to take that answer and divide it by 3. Okay? You can do it all in one, but I would suggest doing it in parts. This is how I would suggest doing it. I would say first do log 9 divided by 50. Divided by log of 3, or not of 3. Yeah, of 3. Do that first. And then I'm going to take that answer and divide it by 3. This is the answer I'm going to round. Don't round before the end. Only round at the end. Because if you round too soon, it could affect your answer. Okay, so the 100th is the 2. The 0 to the right of the 2 says stay there. So negative 0.52. We don't have to check our answers today. The reason we don't have to check our answers today is they're They're exponents. I could have any type of exponent. I could have a 0 exponent. I could have a negative exponent. I could have a positive exponent. Logs, you can't. But exponents, I can have any kind of exponents I want. Okay. All right. So let's look at the last two. 3a and 3b. Okay. Still doing the same thing. We are still doing the same thing, solving. And they're still exponentials. How do we know it's exponential? Because the variable is up in the sky. If the variable is up in the sky, it's an exponential. So my goal is to get this guy 6 and its power, 10x plus 2, by itself. Well, right now it's got a 5 times in front and it's got a minus 2 at the end. So when we're solving, do we do addition and subtraction first, or do we do multiplication and division when we're solving? We always start at the bottom. Addition and subtraction. So I'm going to add 2 to both sides. Okay. Divide by 5. I'm not changing 58 over 5 into a decimal. If it goes in evenly, you can divide it. But 5 doesn't go into 58 evenly. It's like 11 point something. So don't change it to a decimal. Okay. So now I got the exponent, base and the exponent by itself. So now I need to change it to a log. So log with a base of 6. 58 over 5 is the answer. 10x plus 2 is the exponent. So now I have to get x by itself. Okay. So how do I get x by itself? What do I need to do first? Say it again. Subtract by 2. Yeah, subtract by 2. So I'm not going to, so how am I going to write this? I'm going to keep writing the log. And then divide by 10. Okay. So now what I'm going to do is I'm going to put this in my calculator, but not all at once. I'm going to do it little bit by little bit. So first thing I'm going to do is put the log in there. So that's log 58 over 5 divided by log of 6. Okay. So let me do that first. oops, log of 6. Okay. And then what I have to do now is first thing is take that and subtract by 2. So I'm going to take that answer and subtract by 2. So here's that answer there. Subtract by 2. And then after we subtracted by 2, we had to divide by 10. So take that answer and divide it by 10. And there you go. Round that to the nearest hundredth. So the 6 is in the hundredth. The 3 behind it says stay, so negative 0.06. Uh-huh. Yeah, you can write it all in one. Yeah, so you could have gone -2 up here. You could have done that. You could have done -2 and then divided by 10. You could have done it all in one swoop like that. That's okay too. When I do it, I just tend to do it in pieces just because I make mistakes when I do it, when I do something too big. But you can do it, like I said, it depends on you. You can do it all in one thing, or you can do it in pieces. You'll get the same answer. All right. Negative 0.06. All right. Okay, here we go. Let's do this one. Okay. I need to get the green by itself. So I got a negative 10 times, and I have a plus 5. So I have to do the same thing. Start with addition, subtraction. Okay. Divide by negative 10. Now I'm not going to change it to a decimal, but what I am going to do is change it to positive, because negative 73 divided by regular 70 or divided by negative 10 makes 73 over 10 positive. L. So I get log base 19, 73 over 10 equals 19. Oh, sorry, not 19, 9x minus 2. Okay. So I got to add 2 to both sides. Divide by 9. Okay. Now calculator. So remember, this part in here is going to go first. When you write it, you're going to say log of this part divided by log of this part. Get that answer, add 2. Get that answer, divide by 9, you're done. Okay, so let's see. Log of 73 over 10. Over log of 19. Okay. That's that part I circled first. And then I'm going to add 2, divide by 9. Take that answer, add 2. Take that answer, divide by 9. And then that answer you're going to round. So how would I round this answer? How would I round this answer here? 0.297. I know the 9 is in the hundredths. The 7 to the right of it says round up. So how do I round up a 9? There you go. Change the 9 to a 3, or sorry, a 0. There you go. Okay. All right, I'm going to give you one more to do in your notes, and then we'll be done. And then hopefully note the announcements will be posted. So one more in your notes, and then we are done. Let's see. We'll call this 3C. So solve for P, and then round your answer to the nearest thousandth. All right. Okay, so tape is in the back. Tape that in your notes, and then we'll do some practice tomorrow. And then, like I said, Friday we're going to review, and then we have a quiz next week on this stuff here.